Solving quadratic equations with the quadratic formula. So with the quadratic formula, similar to factoring, is it has to be in standard form, which is the ax squared plus bx plus c equals 0. The other thing that has to happen to be able to solve with the quadratic formula is you have to be equal to 0. Is the quadratic formula itself, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, if you notice a couple things, first off, if it takes into account this plus or minus, the two solutions you have already, and the division sign goes all the way across the numerator, including the b and the square root piece as well. What's good about the quadratic formula is it can be used to solve any quadratic equation as long as it's in standard form. So complete the square is nice when you have a b value that is evenly divisible by 2. That's what makes it very simple to use. Otherwise, the quadratic formula may actually be a little bit simpler. Before we start solving, let's talk about one piece of the quadratic formula called the discriminant. So the discriminant is only the part underneath the square root, b squared minus 4ac. That tells us how many and what type of solutions we have. So the first case is if b squared minus 4ac is larger than 0, so that means if it is a positive number, we have two real solutions. That means our parabola, either opening up or down, crosses the x-axis in two places, two unique spots. If we have a b value that is exactly 0, that means we have one real solution. That means our parabola hits the x-axis and then bounces back off. So the vertex is the only place that the parabola crosses the x-axis. And finally, if we have b squared minus 4ac being less than 0, so in this case a negative number, we have two imaginary solutions. And that comes from having a negative underneath the radical. And a parabola like this will not cross the x-axis at all, either opening up or down. In addition, this also can tell us whether we have a rational or an irrational. So irrational numbers are decimals that don't repeat and never end, so kind of like pi. So if you have a square root left over, you end up with an irrational number. A rational number is basically everything else, so a 2 or a third or a fourth, any kinds of those numbers are rational numbers. So if b squared minus 4ac is a perfect square, so 0, 1, 4, 9, 25, any of those numbers that are perfect squares, this will give us rational solutions. Because the square root can be simplified completely out of the solution. If it's not a perfect square, so basically anything else, 2, 8, 17, 104, anything that does not have a perfect square, you will have a square root left over in the solution. This results in an irrational solution. The important pieces are these three here. The right-hand side just kind of goes a little bit further into classifying kinds of solutions. So for the next four examples, it says use the discriminant to determine the number and type of solution. So are there one real, two imaginary? We're not so much worried about this piece over here. We're more worried about this piece here. So with the discriminant, we have to make sure we're equal to 0 and in standard form, just like you would if you were using the actual quadratic formula. So since number 1 is in fact equal to 0 and it is in standard form, we can go ahead and check the discriminant. So b squared minus 4ac is the only piece we're worried about. We're not actually finding the exact solutions, we're just figuring out how many and what kind of solutions they are. So a is the 4, b is a negative 8, and c is a positive 4. So we're going to take b and square it, so negative 8 squared, minus 4 times a, which is a 4, times c, which is a 4. And we're going to see what this equals. So negative 8 squared is 64. Negative 4 times 4 times 4 is also negative 64. And if I take 64 minus itself, I get a 0. So since the discriminant came out as 0, that means I will have one real solution. That's it. Okay, now let's look at number 2. For number 2, we have 9n squared minus 3n minus 8 equals negative 10. So we need it to equal 0 before you can start looking at the discriminant. So we're going to add 10 to both sides of this equation. And so we end up with 9n squared minus 3n plus 2 equals 0. So now we're ready to do the discriminant, which is b squared minus 4ac. So b is negative 3 squared minus 4 times a, which is 9, times c, which is 2. We're going to see what number this is. So negative 3 squared makes 9. Negative 4 times 9 times 2 is a negative 72. And if I subtract those, I get negative 63 as a discriminant. So what that means is, since it is a negative number, that means I have two imaginary solutions. And we're not actually solving it, we're just trying to figure out how many solutions and what kind they are. So pause the video, see if you can try 3 and 4. And here should have been your two solutions for 3 and 4. Now let's look into 5 and 6. So 5, 6, and the rest of this is going to be actually solving these quadratic equations using the quadratic formula. So the first example, number 5, we need to make sure that we're always equal to 0 and in standard form. So we are in fact equal to 0, and then I know that A is going to be a 1, B will be a 3, and C will be a negative 5. Make sure you take the negative signs with you. So the first thing I'm going to do is write down the formula. So the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that I have the formula written out, let's substitute in for the things that we know. So negative of whatever b is. So in this case, b is a 3, plus or minus the square root of b squared, so 3 squared, minus 4 times a, which is a 1, times c, which is negative 5, all over 2 times a, which is 1. The good thing about the quadratic formula, what makes this so easy, is that there's not a lot of difficult math going on. You're doing a lot of simplifying because there's not really any solving because the x is already by itself. So really, we're just simplifying this over here on the right. So negative and a 3 will make a negative 3. Plus or minus the square root of 3 squared makes 9. Negative 4 times 1 is negative 4. Times a negative 5 makes positive 20. 2 times 1 makes a 2. So simplify it down in small increments, little pieces. So now we can even go further by adding 9 and 20 underneath the square root to get 29. All over 2. And then before we say we have simplified fully, we need to make sure that the square root of 29 does not go any simpler. So we're going to try to break it down. But 29 is only 1 in itself, so this guy cannot be simplified. So since the square root cannot be simplified, this would be my final solution. So the solutions to this quadratic equation would be negative 3 plus the square root of 29 over 2, and negative 3 minus square root of 29 over 2. There's no sense in splitting this into its two pieces, because if you wrote negative 3 plus root 29 over 2, or negative 3 minus root 29 over 2, these don't get you any simpler than you already were a minute ago. So when you have a radical left over, it's good to just keep it in the plus or minus condensed form rather than splitting it into its two pieces. Now let's try example number 6. So solve this quadratic equation. Well, the first thing we need to do is make it equal to 0, because that's what the quadratic formula requires. So I'm going to move the negative, I'm going to move 12x by subtracting it, and I'm also going to move the 4 by adding it. So I'm going to do two things at once. So we now have 25x squared. The new value of b is a negative 20x, and then c is that plus 4 that had no like term to combine with. Now, unfortunately, there's nothing that we can divide out of 25, 20, and 4, so we need to actually use these giant numbers. Now, this does in fact factor. I'll show you why it does at the end. But trying to factor with 25, 20, and 4 can be a tedious task. So instead, I'm going to go ahead and use the quadratic formula anyway. So let's write down the formula for ourselves. Now we have the formula, so now we're going to substitute. So the a value is 25, b is negative 20, and c is a 4. So x equals negative of negative 20. We're going to have to condense this double negative at the end. So plus or minus square root of the b value is negative 20 squared minus 4 times a times c, which is a 4, all over 2a. So I want you to take a minute and pause the video and try to get this as simplified as you can. Pause the video and try it out. Hopefully you got to at least here. So x equals 20 plus or minus the square root of 0 over 50. And again, now we need to make sure, can we actually do anything with square root of 0? Well, in fact, yes, we can. So the square root of 0 is 0. So we can actually take the square root of 0. Square root of 0 is equal to 0. Now that we don't have a square root left over, let's split this into its two individual pieces to see if I can get something maybe simpler than 20 plus or minus 0 over 50. So this will split into its two individual solutions. X equals 20 plus 0 over 50, and x equals 20 minus 0 over 50. And we do this because, again, we don't have any square roots left in our solution. Over here on this previous example, we had a square root left over, so we left it condensed into a single solution. Well, 20 plus 0 makes 20, and 20 divided by 50 is 2/5. Over here on the right, 20 minus 0 is again 20, and I end up with the exact same thing I had a minute ago. So in this case, there's really only one solution, 2/5. So when you have no radical left over, be sure to split it apart and see if you can maybe do anything to make it a little simpler. Let's look at example 7. I'm going to start you off with 7, and I'm going to let you finish it on your own. So for example 7, the first thing we need is it equal to 0. So we're going to move over the 13. So we've got negative x squared plus 4x minus 13 equaling 0. Now, you can work with it the way it is. However, a values that are negative create some difficulties. So what we're going to do is we're actually going to change this a value to a positive 1 by taking this entire equation and dividing both sides by negative 1. That will make my a value positive, which is a lot easier to work with. So we have x squared minus 4x plus 13 equaling 0. So take a minute, identify the values of a, b, and c, use the quadratic equation, and see if you can get to the solutions. Pause the video and try this one. So hopefully you got to here. And so 4 plus or minus square root of negative 36 over 2. We need to look at this square root and see if there's anything we can do with it. So it's a negative underneath, so I know that negative is going to come out as an I. So let's start there. And then I also know that the square root of 36 is a 6. So that means the square root of negative 36 is really just 6i. So we have 4 plus or minus 6i all over 2. Now that we have gotten rid of the square root, I'm going to look at the entire fraction as a whole. And I'm going to see if I can maybe do anything to help simplify. So 4, 2, and 6 are all divisible by a 2. So I'm going to simplify the fraction by dividing all of these coefficients by 2. So I end up with 2 plus or minus 3i over 1. We don't really need the over 1 because anything over 1 is just itself. And we also don't need to split apart the 2 plus or minus 3i for the same reason we don't split apart the 1 with the square root of 29. Splitting this up doesn't help me make it any easier because I can't add or subtract 2 and 3i together like I could have up here. So if you have square roots or i's left in your answer, it's easier to leave it as a condensed answer instead of splitting it up into its two pieces. Let's look at a real-world example. So in your backyard, there's a koi pond that measures 6 feet by 8 feet. You have enough concrete to cover a walkway that will result in a total area of 120 square feet as shown in the diagram. What would the width of the walkway be? And so this is in the shape of a rectangle, so I know that my area is going to be length times width. Well, I have the area. It says there's a total area of 120 square feet. So that means my A is going to be 120. Question is, what is length and what is width? Because the length of the pond itself is 8. So I know that from here to here is 8. However, that doesn't encompass the entire distance that I need to go. Well, I know that from here to here is the width of the walkway, which I called X from up here. And that's the same for this side as well. That's also an x. So if I look at this entire side from walkway to walkway, I can say that that length is 8 plus 2x, because I'm going to add all these sides together. X plus 8 plus x. So my length is 8 plus 2x. Now, similarly, the width works almost the same. So the width of this pond itself is 6. However, there's going to be a walkway of x feet on either side. So to get the entire width, we're going to add up the 6 of the pond plus the 2 x's of the walkway. And that will be my width. So the hardest part with these for us is creating the problem ourselves, because we weren't given the equation we actually have to solve. We have to come up with it first before we can actually do any math. Now that we've come up with the basic area formula, we need to get this into standard form to be able to solve it. So we're going to start with double distribution. So we're going to do 8 times 6 to make 48, 8 times 2x to make 16x, 2x times 6 to make 12x, and 2x times 2x to make 4x squared. Combine what we can. 16x and 12x are like terms. So we got 120 equals 48 plus 28x plus 4x squared. Now, I know that all of these numbers, those are some pretty big numbers. These are all divisible by 4. So I'm going to take every one of these and I'm going to divide out a 4 from all of them. So 120 divided by 4 will leave me with 30. 48 divided by 4 leaves me with 12. 28 divided by 4 is 7x, and 4x squared divided by 4 is x squared. Finally, to be able to solve this with either quadratic formula or factoring, you're going to have to move over the 30. You need it equal to 0 before we can start solving. So we've got negative 18 plus 7x plus x squared. Now we're ready to start solving with a quadratic formula. So remember, a is actually still a 1. A is always next to x squared, no matter what order these are written in. So your b value is a 7, and your c value is negative 18. So I want you to take a moment and use the quadratic formula and substitute and simplify down just as far as you can, and then unpause the video. Hopefully this is where you have gotten so far. By substituting and simplifying, I ended up with 121 underneath the square root, and 121 is actually a perfect square. The square root of 121 is 11. So now that we're here, because we ran out, we don't have any radicals, we don't have any square roots, and we don't have any i's. Let's split this into its two pieces that are hidden. So negative 7 plus 11 over 2 and negative 7 minus 11 over 2. So we can actually find legitimate pieces. So negative 7 plus 11 makes 4, and 4 over 2 makes 2. On the bottom, negative 7 minus 11 is negative 18, over 2 makes negative 9. Because this is real world, we need to sit and decide which one of these, if any, solution is not reasonable. So we're talking about, it says, what should the width of the walkway be? So that means I'm looking for a length. I'm looking for a dimension. So lengths are not allowed to be negative. So since a negative 9 would give me a negative walkway width, this is not an actual solution. So the walkway is 2 feet wide. Now, if this had been just a regular quadratic equation, just a mathematical example like the previous examples, then you would have had two solutions being 2 and negative 9. Example 9. Your neighbor is building a fence around his yard. He wants to use the house as one side of the fence to reduce the amount of fencing needed. He knows that the length of the fence should be 2 more than 3 times the width of the fence. Your neighbor wants to enclose 250 square feet inside. What could the dimensions of the fence be? Then determine how much feet of wood he would need for the fence. There's a lot going on here, so my suggestion is to draw a picture if there's not already one given. So it says he's going to draw a fence around his yard. Now, he wants to use the house as one side of the fence. So we've got a house here, and we've got our fencing. So this will be my rectangular fence. So the only fencing I'm going to have is in purple. So it says, what else he knows is he knows that the length of the fence should be 2 more than 3 times the width. So if this is the width, that means my length will have to be 2 more than 3 times the width. So 3 times the width plus 2. That has to be my length. I also know, finally, that he wants to enclose 250 square feet inside. That's the area. Enclosing 250 square feet is the area. If it was 250 around, that would be the perimeter. Now that we have all the information we need, we are going to set up the problem ourselves. So we need to find area being length times width. And so we know that the area, it said, was 250 equals the length, which is 3w plus 2 times the width, which is w. Just like the previous example, we need to now create our own equation. So pause the video and simplify this, get this equation into standard form in order for us to use the quadratic formula. And here's what we have for our values of a, b, and c. 3w squared plus 2w minus 250. So for the quadratic formula, instead of an x, because we're using w's, it's going to change to w equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that doesn't change the actual process here, just changed x into a w. So let's plug in our values. Negative b, which is a 2, plus or minus the square root of b squared minus 4 times a negative 250, which is c, all over 2 times a, which is a 3. Pause the video, simplify this down as far as we can go. So we're going to stop here for just a second. Because this is a distance, decimals are okay. Decimals are actually encouraged because a distance of 25.2 feet makes a lot more sense than a distance of square root of 15. So we're going to use our calculator to help us with the decimal version of the square root of 3004. So I'm going to pull up here, we've got w equals negative 2 plus or minus. The square root of 3004 is about 54.81. And I rounded to 2 decimal places. Now, because we are using actual real world, we are going to split this guy up and find the 2 sides of my answer. So we could have a width of negative 2 plus 54.81 over 6, or we could have a width of negative 2 minus 54.81 over 6. So on the plus side, negative 2 plus 54.81 is 52.81, and divide that out by 6, and we end up with a width of 8.802. On the right, if you simplify this fraction, we end up with a width of negative 9.47. Again, the width cannot be negative, so this solution we have to toss out because we can't have a negative width. So this answers one question that I was asked, part of the dimensions of the fence. So the width is 8.802 feet. Now, the second thing is I need length to finish off the dimensions. So finding the length, remember that length was 3 times the width plus 2. So 3 times my width, which is 8.802 plus 2, will give me a length of 28.41. So the length of my fence has to be 28.41 feet. Now, for the hard part is how much fencing is he going to need? Well, remember that he didn't use 4 sides. He only used 3 sides for fencing. The 4th side was his house. So it's really 2 of the lengths and 1 of the width. So that's the final question it asked. How much fencing? So for the total fencing, you're going to need 2 of the lengths and 1 of the widths. We have this value here at 28.41. And then the width was 8.802. You're going to have 65.62 feet of fence for your neighbor.